Now, coming to the next chapter, that is carboxylic acid. Carboxylic acid. Now, why do we call carboxylic acid? If you see the structure, carboxylic acid has this particular structure. That is, we are having a carbonyl group, C double bond O, and we are having an OH group. Carbonyl plus hydroxyl together is called as carboxylic. Carbonyl C double bond O, and this is your hydroxyl group, OH group, hydroxyl group. Together is called as carboxylic group. But that does not mean, let me clear it, make it clear right from the beginning. But that does not mean that carboxylic acid contains the properties or possesses the properties of both carbonyl group, that is aldehydes and ketones, as well as of alcohol. No, not at all. Not at all. We can say that. Clear? Just for naming purposes, I am saying you that carbonyl plus hydroxyl together is called as carboxylic acid or carboxyl group. We can say that. Carboxyl. Carbonyl plus hydroxyl is called as carboxyl group. And it's as a result it is called as carboxylic acid because it releases H plus ion. I will show you how it is. But that does not mean that it has got the properties. It possesses the properties of both carbonyl group as well as hydroxyl group. No, nothing to do with that. Clear? So in this way. So what you find is that carboxylic that is acid, as you can see the structure, it is trigonal planar. As you can see it is trigonal planar. So this carbon atom is sp2 hybridized. This carbon atom is sp2 hybridized. As you can see this, it is trigonal planar structure. The bond angle is here, it is 120 degree. Alright, and hence this particular carbon atom is sp2 hybridized carbon atom. We can say that. Clear? That is COH group, the carbon atom is sp2 hybridized and it is polar in nature. Alright, definitely, because it has got two polar group. One is carbonyl group, another is hydroxyl group. So it is much more polar. Much more polar. Listen carefully this point. It is much more polar than aldehydes and ketones as well as alcohols. It is much more polar in nature with the presence of the two carbonyl group. We can say that. And at the same time, it also shows resonance. We can say that. It also shows resonance. Now, how it shows resonance? Now see here. Here oxygen, definitely 4 electrons are there. This is, let us say, the structure 1. Now what is going to happen? This pair of electrons will come here. So hence the canonical structure which is being formed is this, we can say. It is 1, 2, 3, 4, 5, 6 negative charge, and here it is, what you can say, this particular one you will be having it. So here what you find, the carbonyl carbon also develops positive charge. This is in structure 2. The carbonyl carbon develops positive charge. Your deficiency of electron, 3 bonds are there, and this is negative. We can say that. Now what is going to happen? From structure 2, what is going to happen? This pair of electrons will come here. This pair of electron, and hence what I am going to get it here. That is this particular one, and here double bond, and this particular one is this. Now the carbonyl carbon, you can see it is neutral. The carbonyl carbon in the first, what you can say, this group, and the third group, in the first structure and the third structure, you can see it is neutral in nature. But here the third structure is more comprehensive and much more accepted, much more stable in the, because it is showing resonance. No? This is a resonance structure, and these are the canonical structure. I have done it. It shows resonance. Energy is distributed. Alright, resonance means definitely energy is distributed. When a particular molecule shows resonance, when a particular structure shows resonance, what does it mean? Energy is distributed and stability increases. So here it is more stable in nature. So what I want to say is that the third structure is more convincing, more stable than any of the structure that is 1 and 2. Why? Because here the oxygen atom is negative as well as positive. That means energy is distributed equally. We can say that. So we are having both negative and as well as positive. What you can say, that is oxygen atom, energy is distributed throughout, and as well as the carbon atom is neutral in nature. Of course it is neutral in nature in structure 1 also, but structure 1 does not contain the oxygen negative and positive charge. Negative and positive means what? That only makes it highly reactive. That only makes it highly reactive. It is this too, the presence of this negative and positive charge only makes it highly reactive. So in this structure it's much more stable, it is much more convincing, and it is much more reactive. We can say that energy is also completely distributed here in it. Got it? So in this way, it possesses the delocalized electron. The electron is also delocalized. You can see that the electron delocalized, because again this can come here double bond, and again this can go here. It is single bond. It can form. So it is again, it can be delocalized. That means from here we can come back to this structure again. From here we can come back to this structure again. So hence it is resonance. We can say that energy is distributed thoroughly. Got it? And it's more stable, more convincing, and more reactive in nature, we can say. And also it shows it is more polar in nature. You can see that polarity is well defined here in this particular structure. Negative as well as positive poles, both are being there. That is well defined in this particular structure. For that reason I said this structure is more convincing in nature. Now what I find is that this is about the structure of carboxyl group I was explaining you. Now coming to the acids. Now if I put here H atom, if I put H atom here, then what will I get? I will get formic acid, HCOH. If I put CH3 atom, I will get CH3 group, then I will be getting CH3COH. Now this is called formic acid. Now formic acid is a common name. IUPAC name is methanoic acid. Methanoic, M-E-M-M. Methanoic acid. IUPAC name is. Why methanoic? Because one carbon atom, meth, and it is carbon single bond, and secondary suffix is oic acid, so methanoic acid. Similarly, this is what? Ethanoic acid or acetic acid. Now, as I was saying you, formic acid, the name, it has come from the word, we can say that, forum, we can say, which is nothing but ant, we can say. And so hence we get this particular formic acid from the bites or from the sting of the ants and the wasps. When the ants and the wasps, they stings you, they bites you. So that is, an irritations is there and itching is there. It becomes red and also it burns. We can say the burning sensation is there. That is nothing but it leaves in the stings of the ants and the wasps. Formic acid is there, and that it leaves in your body. Got it? Due to which this itching and this burning sensation, or this whatever you can say, irritations is being taking place. From there, that is from the word that is formic or forum or formi. We can say we have got the word formic acid. Got it? Similarly, ethanoic acid is also called as vinegar. Vinegar or acetic acid is also called as acetic acid or vinegar. That is acetum. Acetum means what? Vinegar, we can say that. Clear? From there we got it. Similarly, in this way many names are there, like butyric acid from butter, tartaric acid from tamarind, we can say that. Clear? Malic acid from apples, we can say. Clear? In this way, these are the sources of different, what you can say, carboxylic acid. Some of the sources I told you, that is butyric acid, we are getting it from butter, that is butyrum, we can say that. Clear? Formic acid, we are getting it from the ants. I said you, that the Latin name is formic or formi, or it is formica, or whatever you can say that. Different, see, the naming is according to different ages, the name has changed slightly. Got it? Initially we are known as formica, then formi, then forum. In this way the name has changed. Whatever it is, ultimately it is called as formic acid, which has come from the ants and the wasps. From there we have got the name, just to remember it. Got it? Similarly, acetic acid, we have come from the word acetum, means vinegar. Got it? That's the source. That is, hence it is also called as vinegar, we can say that. Clear? Similarly, butyric acid, that is butyrum, means butter, we can say that. Malic acid, we are getting from apples, we are getting tartaric acid from tamarind. In this way, oleic acid from tomatoes. In this way, so many are there, we can say that. Clear? Fine. So in this way, we get the name of this is the common name as well as the IUPAC name I said you. Got it? Now more of the IUPAC name I am going to come to it. More of the IUPAC name. So now the first is, that is the carboxylic acid is represented by the general formula RCOOH. Got it? The general formula of carboxylic acid is RCOOH. This is general formula of carboxylic acid, so to say, where R is any alkyl group. Just now I have discussed with you some of, we can say that. So we have got, if H is there, then formic acid or ethanoic acid. If CH3 is there, ethanoic acid. If CH3CH2 is there, then propanoic acid. Then if CH3CH2CH2COH is there, then we can say butanoic acid. In this way it goes on. Or butyric acid, the common name is, we can say that for the butanoic acid we are having it. In this way, now what you can say, this saturated monocarboxylic acid containing that is only the carbonyl group are also called as fatty acids. They are known as fatty acids because these are usually used to make the fats. Got it? That is the higher members of the aliphatic carboxylic acid. Got it? What I said? Saturated, that is monocarboxylic acid containing only the carbonyl, carbonyl I'm saying, carboxyl group. I'm very sorry, it is not carbonyl. Containing only the carboxyl group are also called fatty acids. But which are higher carboxylic acids? Higher means containing 12 to 18 carbon atom present in it. Containing mainly 12 to 18 carbon atom present in it because they are the source of the fats. We can say that. They are basically solids. That is occurs in natural fats and esters, this particular acids. Alright. 12 to 18 carbon atoms, the carboxylic acids basically occurs in natural fats and esters. I said it is the source of the fats. That is, it can be obtained. That is, fats can be obtained, esters can be obtained by hydrolysis of this particular acids. We can say that. Clear? So hence it is also called as fatty acids. Those carboxylic acids. That is higher carboxylic acid. We can say that. Got it? Now, similarly, if it is aromatic acid, then it will be ArCOOH. If it is aromatic acid, we can say that. Ar means any aryl group. Like C6H5COOH. It is called as benzoic acid. Benzoic acid means, I mean to say this one. If I draw the structure, then this is your benzoic acid. Why it is benzoic? Because I said you, benzene ring attached to carbon atom is called as benzo. Benzene ring attached to carbon atom is called as benzo. Benzene ring attached to CH is benzal. Benzene ring attached to CH2 is benzyl. Alright, I've told all these things. So benzo plus oic acid is called as what? Benzoic acid. We can say that. Similarly, if you are having, that is CH3 group attached here, CH3 group. With the benzene ring, we are having CH3 group attached to it and we are having COOH. What is this known as? Now benzene ring CH3 is toluene and oic acid is there. So it is known as what? Toluic acid. Rather I should say orthotoluic, because in ortho position it is there 1, 2, ortho, you can see. Alright, that is 1, 2 which is ortho, so it's orthotoluic acid, or the IUPAC name is nothing but it is known as methyl benzoic acid, 2-methyl. This is 1 and this is 2, of course, because functional group is first carbon atom. So 2-methyl benzoic acid, we can say that. Clear? The IUPAC name. Similarly, we can also have this particular compound. Now we can have many, understood, many compound we can have it, like CH2COOH, CH2CH. It is called as phenyl, what you can say, acetic acid. Phenyl. How it is phenyl? See, it is phenyl and 2 carbon is there. So it is phenyl ethanoic acid or phenyl acetic acid. See here, this C6H5, this benzene ring is your phenyl. From benzene ring, if you remove one hydrogen, then only you will be adding this particular group. No? So if you remove one hydrogen from benzene ring, what is that called as? Phenyl. So hence it is called phenyl and this is acetic acid, or IUPAC name is phenyl ethanoic acid. 2 carbon is there, eth, for that particular reason. Carbon single bond is an and COH is oic acid. So phenyl ethanoic acid, we can say that. Clear? In this way, we can have monocarboxylic acid. Monocarboxylic acid means all these one which I was talking to you, all these. In aliphatic, aromatic, whatever I have told you the formula, all contains, you can see, one COH group. All these particular formula which I said, which I discussed with you just now. So all this contains one COH group. So one COH group means it is known as monocarboxylic acid. If it contains one COH group, whether it is aliphatic or whether it is aromatic. Got it? If it contains. Now if it contains 2 COH group, 2. For example, here it is, you can see COOH, single bond COH. What is this known as? It is known as nothing but ethane 1,2-dioic acid. 2 carbon eth, single bond N, ethane 1,2-dioic acid. See, I am writing. Ethane 1,2-dioic acid, we can say that. Or oxalic acid, the common name is. Oxalic acid, you know it, definitely. CH2COOH. This is also dicarboxylic acid. What is known as? Malonic acid. This is called as malonic acid. Alright, then we are having CH2COOH. Now this name you need to remember it, understood? For that reason I am writing it. This name you have to remember it. Basically the common name. IUPAC name is not difficult at all. It's not difficult. IUPAC name. Like this one, what is IUPAC name? 1, 2, 3 carbon atom. Propane 1,2-dioic acid. Finished. IUPAC name, so easy. 1, 2, 3, prop. Single bond N, propane 1, 2, dioic acid. First and 1, 3, sorry. Propane 1, 3, dioic acid. 1, 3 it is, not 1, 2. 1, 3, dioic acid. Similarly, what is that? 1, 2, 3, 4. So, butane 1, 4, dioic acid. But the common name is succinic acid. Succinic. The common name you need to remember. IUPAC name I don't think so. You need to remember. You have to understand it. IUPAC. That is succinic acid. Similarly, if you have CH2, CH2, COOH, we can say that. Again CH2, CH2, COOH. What is that? It is nothing but known as adipic acid. It is called adipic acid. Similarly, CH2, CH2, COH, CH2, CH2, adipic acid. Alright, similarly, we are also having, that is in case of aromatic. Suppose first and second. I am taking this as first and this as second. This is first, second, we can say, or first, second, whatever it is. So it is known as phthalic acid. Spelling is PHALIC, phthalic acid, we can say that. Now, first and second, if it is there, it is called as phthalic acid. If first and third COH group is there, listen carefully. First and third, it is first and second, so phthalic. So first and third is there, it is called as isophthalic acid. Isophthalic, ISOPHTHALIC. ISOPHTHALIC. If it is first and third, 1 and 3. Now if it is 1 and 4, here the COH group will come here, first and fourth. It is known as terephthalic acid. TEREPHTHALIC. Terephthalic acid. It is said to be as. If first and fourth COH group is there along with the benzene ring, it is called terephthalic acid. Or IUPAC name, what you can say? Benzene 1,4-dioic acid. We can say that. Clear? So in this way, this is about your, that is dicarboxylic acid having COOH twice. Alright. Now we will come to tricarboxylic acid. Tri, having 3 COH group present in it. We can say that. Now see here, CH2COOH, similarly CHCOOH, similarly CH2COOH. It is called as tricarboxylic acid. Tricarboxylic acid, we can say that. Tricarboxylic acid. Now, very simple it is. I will remove this H and instead of that, I will put it here OH. Alright, just I will remove this H and instead of that, I will put it OH. You know what is the name? It is very common. It is found in lemons. This acid is found in lemons. What is that? Citric acid. That is said to be as. Citric acid is found in lemons. So this is a formula of citric acid which comes under tricarboxylic acid. We can say that. In this way, many more names we can have it. So in your chapter, in the beginning of the chapter, you can see that is the IUPAC name, the common name. A chart is given for both aliphatic and aromatic, which I discussed with you. You please do it this particular, what you can say, the chart, you learn it, that particular common names. IUPAC name, no need to learn it all, because IUPAC name is always guided by rules. And if you remember the rules, no need to learn the IUPAC name, and you can't learn it also. It is better to learn the common names, we can say that. Clear? So the higher fatty acids are called as palmitic acid is there, oleic acid is there, stearic acid is there. Stearic acid is what? C17H35COOH, stearic acid. Similarly, we have got palmitic acid. It is nothing but what you can say, 15H31COOH. We can say that. Clear? So in this way, what you find is that we are having the higher carboxylic acid, which I discussed with you, which is known as fatty acids. We can say that. Similarly, in carboxylic, in what you can say, aromatic acid, we have also got phthalic acid. Apart from that, we are also having, that is cinnamic acid. Cinnamic acid, I have discussed in, not in this chapter, in other chapters I have discussed with you. Cinnamic acid, CH double bond CH single bond COOH. It is called as cinnamic acid. We can say that. Apart from phthalic acid, we have also got a very important one. This one is cinnamic acid, so to say. Alright, clear. So this is all about your IUPAC and the common name, the structure of carboxylic acid, the resonance structure, which is more stable, whether it is polar or not, it is highly polar, I have said you. Alright, all these things we discussed about the carboxylic acid, so to say. Now, it's a very reactive group, and why it is acid, that's very important. Now, thing is, why it is acid. Now, see here, COOH, alright, COOH. Fine. So here the lone pair of electrons is there. What will happen? Now oxygen is more electronegative than hydrogen, you know that. Got it? Now oxygen will always have a tendency, got it? Will always have a tendency to, what you can say, take the pair of electrons from H atom. To take the pair of electrons from this particular H atom. Always have a tendency because oxygen is more electronegative than hydrogen. So when this pair of electrons will be taken by oxygen, then what will happen? We will have CO, this is there, then this and this. Negative charge because due to excess of electron, negative charge, and due to deficiency, H plus ion is released, we can say, because the cleavage of the bond takes place. Cleavage of the bond takes place, and hence H plus ion is released, you can say that. Due to the release of H plus ions, we say carboxylic acid is acidic in nature. Understood? Why this particular group we call it as acid? Because it releases H plus ion, we can say that. How? In this way, it releases. Now if any particular group is there, which is an electron withdrawing group, it will withdraw electron from carbon. Carbon will electron withdraw from oxygen, and oxygen will withdraw electron from hydrogen, and hence the cleavage will take place easily. Remember it. If an electron withdrawing group is present here, electron withdrawing group, then the acidic character is going to increase. Why? Because this is going to withdraw electron from carbon, carbon from oxygen, oxygen from hydrogen, and hence the cleavage takes place easily here, and due to which H plus ion is also readily released. Alright, so electron withdrawing group means, for example, suppose an NO2 group is attached here. For example, suppose we are having an HCl group attached here. They are the electron withdrawing group. Alright, halogens are attached here, NO2 group is attached here, CN is attached here, mainly multiple bonds and halogens. They are the electron withdrawing group. So if it is attached here, it will increase the, what you can say, acidic character. But suppose if I use here an alkyl group like CH3, C2H5, it will decrease the acidic character. Alright, for that particular reason, remember it. Formic acid, HCOOH. Now formic H atom is neither donor nor withdrawing, isn't it? So formic acid, listen carefully, is more acidic than acetic acid. Because in formic acid, H atom is there. In acetic acid, what it will be? CH3 group will be there. And CH3 is a donor group. Donor means it will donate to this carbon. Now, will this carbon atom withdraw electron from oxygen? Will the oxygen atom withdraw electron from hydrogen? No, with difficulty. It will withdraw, but with difficulty. Compared to this formic acid. Compared to this, suppose if I use here CH3, then acidic character is going to decrease compared to formic acid. Why? Because this is an electron, what is that? Donor group. It will donate to this carbon. This carbon will donate to this particular oxygen. So will oxygen atom readily withdraw electron from hydrogen? No. It will, but it will not readily withdraw electron from hydrogen, due to which acidic character decreases. So hence formic acid is very strong acid compared to acetic acid, compared to propanonic acid, compared to butanoic acid. Means as the alkyl group goes on increasing, acidic character decreases. Because as plus I effect, alkyl group goes on increasing means carbon atom goes on increasing, plus I effect goes on increasing. As plus I effect increases, acidic character decreases. Alright, so this you need to remember it. In this way, we can say that carboxylic acid is more acidic in nature, and moreover, what you find is that here, that is what you find here, this particular structure in the reactant side, and here we are having this structure in the product side. Now this is more resonance stabilized, this particular one. Then this particular structure we can say that this is stabilized due to resonance more. So hence equilibrium always favors in the forward direction. Alright, if you ask me that out of these two structures which is more stable, then this is more stable. Why? Because it is stable due to resonance. How it is stable due to resonance? Because this negative charge is equally distributed throughout this particular, what you can say, oxygen, this and this oxygen, due to which this oxygen is also slightly electronegative, del minus, and this also is slightly del minus. Then at that time, how will you show the structure? You will show the structure, the diagram in this way. In this way, you will show it. This means that is the negative charges is equally distributed throughout the two oxygen atoms. Alright, due to which what you find is that this structure, as negative charges is equally distributed, that means it is delocalized. And I have said you always, whenever you are delocalizing the charges, that means you are distributing the energy. As you are distributing the energy, less energy is remaining in the compound. If less energy is remaining in the compound is more stable in nature. So hence it is more stable due to resonance compared to this. As it is more stable, the equilibrium is favored in forward direction. As equilibrium is favored in forward direction, H plus ion is readily released. Due to this reason, this structure is more stable and H plus ion is readily released, and hence carboxylic acid is more acidic in nature. Got it? Carboxylic acid is more acidic in nature. Due to this reason also carboxylic acid, because there are many compounds there. Like in alcohol, you have also seen H plus ion is released in alcohol. Got it? You have read it in alcohol chapter, ROH. Here what you find? It forms RO minus and H plus. Here also you can see that is H plus ion is released, but is it alkoxide ion stable due to resonance? No. Alkoxide ion is not stable due to resonance, due to which the equilibrium is favored in backward direction, and hence H plus ion it's not readily released. Little bit of H plus ion is released, and hence alcohol is less, very slightly acidic in nature. It is less acidic than water also. What did you have studied? Water is more acidic than alcohol. So release of H plus ion does not mean it is acidic. At the same time, this particular product has to be stable, because if this product is stable, then only the equilibrium favor in forward direction. So here in carboxylic acid that takes place. This product is stable, I have explained you, hence equilibrium is favored in forward direction. Due to this reason, it is a strong acid, it behaves as a strong acid, carboxylic acid. Alright, so if you compare carboxylic acid and alcohol, then here H plus ion is readily released, and hence this also is stable then compared to alkoxide ion, and hence it is more stronger, more acidic in nature. Got it? So this all you understood about the nature of the structure of the acid. Thank you.